Hello everyone, my name is Dhruv and this is my third learning demonstration for environmental science. In this presentation, I'll explore how plate tectonics shape Earth's surface, creating mountains, volcanoes, earthquakes, and more. I'll also discuss the human impact of living in tectonically active zones and how countries like Japan prepare for related natural disasters. Moving on, to understand how Earth's surface changes, we need to start with plate tectonics. The outer layer of our planet, called the lithosphere, is broken into massive slabs called tectonic plates. These plates float atop the semi-fluid asthenosphere, asthenosphere and are constantly moving. Their movement is powered by convection currents in the Earth's mantle, which is driven by the heat from the core. The interaction of these plates at their boundaries is responsible for much of the Earth's geological activity that includes earthquakes, volcanic eruptions, and the formation of mountain ranges. There are three main types of plate boundaries, and each plays a unique role in shaping Earth's surface. At convergent boundaries, two plates move toward each other. If one plate is oceanic and it gets pushed beneath the other in a process called subduction, often forming volcanoes or deep sea trenches. When two continental plates collide, they push upward to form massive mountain ranges like the Himalayas. At divergent boundaries, plates move apart from each other. This allows magma from the mantle to rise and create new crust, as seen at the Mid-Atlantic Ridge or the East African Rift. At transform boundaries, plates slide past one another horizontally. This side-by-side movement causes earthquakes, such as those along the San Andreas Fault in California. Understanding these boundaries is key to predicting geological events and also their implications. Convergent boundaries. Now, these occur where tectonic plates move toward each other. When an oceanic plate converges with a continental plate, the denser oceanic plate is forced beneath the lighter continental plate in a process that is known as subduction. This creates deep ocean trenches and magma that rises to form volcanic mountain ranges such as Japan's Mount Fuji. However, when two continental plates collide, neither is subducted due to their similar densities. Instead, the crust crumples and folds, pushing upward to form mountain ranges. The Himalayas, where the Indian plate collides with the Eurasian plate, are a dramatic example of this process in action. Convergent boundaries are among the most geologically active zones on the Earth, producing powerful earthquakes, explosive volcanoes, and dramatic changes to the landscape. Now, here are the images of examples of Mount Fuji in Japan and the Himalayas in India, and how they are representation of convergent boundaries moving against each other, resulting in the formation of Mount Fuji, which is a volcano in the case of an oceanic and a continental crust, and the Himalayas, which is an example of the formation of fold mountains, which is the result of two continental plates converging within themselves. Now, divergent boundaries occur where tectonic plates are moving away from each other. In oceanic settings, this process forms mid-ocean ridges, where magma from the mantle rises to the surface, cools, and creates new crust. One of the best known examples is the Mid-Atlantic Ridge, which runs down the center of the Atlantic Ocean and is slowly pushing Europe and the Americas further apart. On land, divergent boundaries create rift valleys, where the Earth's crust is stretched and thinned. The East African Rift is a prime example. Eventually, it may lead to the formation of a new ocean basin as the African continent splits. These boundaries are less explosive than convergent zones, but they are very crucial to the constant renewal and reshaping of the Earth's surface. Here are the two primary examples of divergent boundaries: the Mid-Atlantic Ridge and the East Africa Rift Valley, where plates are noticeably diverging from each other, creating new mantle with the cooling down of the erupting lava. Transform boundaries. Now, these occur when the two tectonic plates slide past each other horizontally. This sideways movement causes a buildup of friction as the plates grind against one another. When the stress exceeds the strength of the rocks, it is suddenly released as an earthquake. One of the most famous examples is the San Andreas Fault in California, where the Pacific Plate and the North American Plate move in opposite directions. This fault system is responsible for many of California's major earthquakes and remains under constant geological monitoring. This is the reason why there are a lot of earthquakes in California. Unlike convergent or divergent boundaries, transform boundaries do not create or destroy the Earth's crust, but they are highly active and dangerous zones, especially for human populations, like, for example, in California, that live in the state of California and also in states like Oregon and Washington. Now, talking about Japan, Japan is one of the most tectonically active countries in the entire world. It sits at the intersection of four major tectonic plates: the Pacific Plate, the Philippine Sea Plate, the Eurasian Plate, and also the North American Plate. At these boundaries, intense tectonic activity occurs. The Pacific Plate is subducting beneath the Japanese archipelago, creating a deep ocean trench and triggering frequent earthquakes and volcanic eruptions. This tectonic arrangement makes Japan especially vulnerable to disasters. A notable example is the 2011 Tokyo earthquake, where a magnitude 9.0 quake of the northeastern coast of Japan. It generated a massive tsunami that caused widespread destruction and loss of life. Japan's tectonic location demonstrates how plate boundaries shape not only landscapes but also the lives of the people who inhabit them. Living at the intersection of four tectonic plates, Japan has developed some of the world's most advanced disaster preparedness systems. To reduce damage from earthquakes and tsunamis, buildings and infrastructure in Japan are often designed to be shock absorbent and flexible, with strict building codes enforced in urban areas. Japan also maintains a sophisticated early warning system that can detect seismic waves seconds before they reach the surface, giving people time to take cover or evacuate. These alerts are broadcast through cell phones, television, and public sirens. Public education and earthquake drills are another key part of Japan's preparedness strategy. Schools, businesses, and communities routinely practice how to respond to disasters. Government agencies also work together in real time during emergencies to coordinate evacuation, rescue, and relief efforts. This combination of technology, education, and proactive planning has saved countless lives and minimized the impact of past disasters. Human impact and risk zones. Tectonic activity doesn't just happen to shape the natural world, it directly affects human life. More than a billion people live near tectonic plate boundaries, placing them at a very high risk for earthquakes, volcanic eruptions, and tsunamis. Many of the world's largest cities, like Tokyo, San Francisco, Manila, and Istanbul, are located in these zones. Now, these regions face the constant challenge of balancing urban growth with disaster preparedness. Infrastructure must be designed to withstand seismic events, and emergency planning must be a part of everyday life. Understanding where tectonic plates or tectonic risks are concentrated helps inform decisions about urban development, building codes, insurance policies, and also international aid. Ultimately, while we cannot stop tectonic processes, we can adapt and prepare. That can help us to minimize the loss of life and property when these natural disasters such as earthquakes, volcanic eruptions, and tsunamis actually strike. By placing this world map side by side, What I'm trying to portray over here is that how many of the world's most populous regions coincide with tectonic boundaries, which underscores the importance of integrating geological understanding into urban planning and disaster preparedness. As you can see in the visual itself, Japan, which is a very, very highly and densely populated country in comparison to the other regions of the coastal regions of Russia, this shows that this is a prime example of how Japan has prepared itself in relation with all of the natural disasters it has faced in the past and is destined to face in the future as well. While tectonics is a topic rooted in geology, its effects stretch far into the realm of human geography. Plate boundaries don't just create mountains and earthquakes, they help determine where people settle, how cities are built, and how nations respond to risk. Many tectonically active regions, such as coastal Japan, are economic powerhouses and major population centers. Despite the danger, people continue to live in these zones because of fertile soil, trade access, and historical development. This overlap of geological risk and human density creates enormous challenges. When disasters strike, the consequences are not just natural, they are social and economic. That's why understanding tectonic activity is crucial not just for scientists, but for urban planners, policymakers, engineers, and also communities. We must view tectonics not just as a force of nature, but as a factor that actively shapes how and where we live. So, in conclusion, plate tectonics is the engine behind many of the Earth's most powerful forces. From the rise of mountain ranges and the formation of ocean basins to the devastation of earthquakes and volcanic eruptions. Understanding the three types of plate boundaries, convergent, divergent, and transform, not only helps us to predict where the changes occur, but also to shape human life. More importantly, we have seen how tectonics intersects with human life. Over a billion people live in tectonically active areas, making disaster planning, infrastructure resilience, and public awareness very essential for human survival. From the peaks of the Himalayas to the quake-prone streets of Tokyo and Los Angeles, Earth's dynamic crust continues to shape not just our planet, but also our civilizations. On that note, thank you for listening, and I hope you can incorporate some of the ideas that I've talked about in all of my learning demonstrations, whether it be whether it be in regards with pollinators, lithium mining, and also now about the plate tectonics and how we can actually help our community to become more aware of these topics and ultimately help our community to ensure that our environment is well taken care of. Thank you so much for listening.